get started, we'll let people kind of walk in as they get here. So, guys, welcome to Couchbase Connect. This is the first session of the conference, and we're really excited to have you here for the next few days. And I'm especially excited to talk to you today about Couchbase Mobile. So, my name is LeClerc, and I am the product marketing manager for Couchbase Mobile. So before I get started, I've been reminded to tell everybody to download the Couchbase Connect app if you haven't done that yet. All the agenda's on there. You can take photos. There's a great feed going on, so download that. There's also surveys that we would appreciate you taking the time to respond and give us your feedback on what you think so far. So this is where you can get the application. So introduction to Couchbase Mobile. Before I get started, I just want to do a quick poll. Who here is using Couchbase or has used Couchbase to build an app? Good, OK. So a few of you. And what about Couchbase Mobile? All right, same couple of folks. Good. So we have a good mix of people who know Couchbase and people who are new to it. So excited to have you here today. So just to kind of quickly go through the agenda, I'm going to start off by talking about the mobile challenges for today's enterprises. We'll go through the product, so we'll talk about Couchbase Mobile from a high level. I'm going to talk a lot about common mobile use cases we see in some real-world stories around how our customers are solving some pretty cool, some pretty interesting problems with the technology. And then I'm going to spend a little bit of time talking about the conference over the next 2 days, specifically the mobile track and what you can expect for the next 2 days here. Then I have some time for Q&A as well. OK. So let's start. Mobile challenges for today's mobile apps. So storing, accessing, transporting, and securing data outside the cloud can be really hard. Development time's expensive. Support and maintenance of your app can be really costly. You have to solve for data management concerns in your entire stack. And even with a great UI, even if your backend isn't robust, then your app experience is going to be poor. So according to Bach & Company, they're a leading research company in the area of mobile apps. These are the key challenges that developers face when building mobile apps. So it's easy integration with the backend database. It's the ability to work offline. It's cross-platform support. It's storing all types of data, including multimedia data and sensor data. And it's IoT support. So on this chart here, you'll notice that all but one, which is cross-platform support, is directly a data management concern. And even then, cross-platform support is partly a data management problem. And, so as those results showed, offline support is a big challenge to build into applications, but it's something that we're hearing so much from developers. And Forrester has actually found the same. So in their recent report, the Offline Mobile Challenge, Forrester talks about how adding offline capabilities is critical for virtually every mobile application, yet is the most difficult thing to build. In fact, building this custom for an app will more than triple the development cost. So as they say, offline capability will be a consideration for nearly every future modern application and is often the most expensive and valuable infrastructure service mobile development teams will implement. OK, so we understand and we agree on the high-level challenges around building mobile apps. And as we saw, those are primarily data management challenges. So now let's drill down one step further and take a look at the key criteria to consider when choosing a database for your mobile apps. So first is cross-platform support. You'll want to choose a database to support the platforms you need for your mobile application. So are you going to deploy on just a single platform like iOS, or are you going to deploy on multiple platforms? Are you looking to support non-mobile platforms that live on the edge of networks, basically anything you wouldn't normally consider to be a mobile device like a phone or a tablet? And last, are you taking your future needs into account? So you might be rolling out with an iOS app today, but down the line, maybe you'll want to add Android support and Windows support or other platforms. So when you're choosing a database to support your applications, make sure you take your current platform needs into account, as well as your future platform needs into account. OK, so next we have security. It's important to access, transmit, and store data securely. To cover this completely, you need to address a few things: authentication, data at rest, data in motion, and read-write access control. Authentication should be flexible and allow for the use of standard, public, and custom authentication providers. Support for anonymous access is also important for many apps. For data at rest, on the server and the client, you'll want support for both file system encryption and data level encryption. For data in motion, communication should be over a secure channel like SSL or TLS. And for data read-write access control, the database should offer granular control over what data can be accessed and modified by users. Okay, so moving on to data modeling flexibility. You need the ability to describe your model in an efficient way. And you need the ability to evolve your model as needed. So we all understand that mobile apps evolve very quickly from version to version. And your data modeling concerns of today may be different from your data modeling concerns of tomorrow. So choosing a technology that allows you to iterate that data model as you learn about your market and customers is very important. Next, we have synchronization support and optimization. So if you want your local database to easily integrate with your backend database, synchronization is your way to do that. It's also important to have the ability to control how the system syncs. So that includes replication strategy, conditional replication, and replication filtering. For replication strategy, you'll need support for continuous, polling, one-time, and push. You should also have the ability to use a combination of these strategies. For conditional replication, you may need to replicate data only under certain conditions. So think about when your device is on Wi-Fi or only when it has sufficient battery power. And for replication filtering, you should have the ability to replicate data, but not replicate some data, but not other data. It's also useful to be able to conditionally filter data based on conditions. So for example, you may only want to synchronize large videos or photos while you're on Wi-Fi, but not on a cellular network. Okay, so then we have conflict resolution. So we just talked about synchronization, something that almost all mobile and IoT apps require. Synchronization introduces the fact that your data can be changing in multiple places at the same time, which introduces conflicts into the system. And those conflicts need to be resolved. So a mobile database needs to support a mechanism for resolving those conflicts. The flexibility of the conflict resolution mechanism is important, and that also should allow for resolution automatically on the device, in the cloud, by an external system, and by a human. Okay, then we have scalability. So you need a system that can scale up when with your needs as your storage capacity needs increase, and then can scale elastically real time for peak and off-peak capacity demands. So for example, maybe you want to scale up during the day when everyone starts using your app, and then scale it down at night when less people are using it. Okay, moving on to topology support. So topology is really about how you want to deploy your system. There are a lot of options when you talk about topology. Typically, the most popular ones we see are star, which is by far the most popular, tree, which is probably second most popular, and mesh, which is probably third most popular. And mesh is many times referred to as peer-to-peer, especially on the edge. So starting off, star topologies are the easiest and most popular topologies to use. Often, and especially in the enterprise, a more complex topology like tree is often needed. So flexible topology beyond star is important. Like I talked about earlier, take your future needs into account. Today's star might be what you need, but if you need a different topology in the future, make sure your database can support that. Okay, so now that we've talked about the key criteria, let's talk about Couchbase Mobile. So this is Couchbase Mobile, the full stack data management solution that resolves all of your data storage, access, transport, and security concerns across the entire application stack. Couchbase Mobile consists of 3 different components. So you have Couchbase Lite, which is a full-featured embedded NoSQL database that runs locally on the device. It includes complete offline support with full CRUD and query functionality. Next, you have Sync Gateway. So Sync Gateway is a secure web gateway that enables synchronization and data access over the web. It includes configurable synchronization, REST, stream, batch, and event APIs for data access and synchronization. And then you have Couchbase Server, which is our flagship, highly scalable, blazing fast NoSQL database server. And then running along this entire stack, you'll see on the bottom security. So we have built-in enterprise-level security throughout the entire stack. This includes user authentication, user role-based data access control, secure transport over TLS, and 256-bit AES full database encryption. Okay, so let's dive into the components of Couchbase Mobile, and we'll start with Couchbase Lite. So like I mentioned, Couchbase Lite is a full-featured embedded NoSQL database that runs locally on the device. We're very focused on cross-platform portability, and we've built native from the ground up for each platform. We support all the major mobile operating systems. That includes a Cocoa version for all the Apple technologies, so that's iOS, tvOS, OS X. Our Java version supports any platform that can run a J2SC compliant JVM. So that's Android, Linux, Windows, and a ton more. And our C# version supports all the .NET runtimes. So that's Microsoft, Mono, and Xamarin. You can store both JSON documents and blobs. Couchbase Lite is very lightweight. It has a small footprint of about 500 KB on most platforms. Java is about a meg. And data is secured on the device using 256-bit AES full database encryption. And in Couchbase Mobile 1.2, we added TTL support for auto-expiring documents. OK, moving on to Sync Gateway. So Sync Gateway is a secure web gateway that enables synchronization and data access over the web. It has configurable REST, stream, batch, and event APIs for accessing and managing data over the web. User authentication is pluggable. So out of the box, it has support for popular public login providers like Facebook. It has support for basic authentication, or you can write your own custom provider. And we added OpenID Connect support for OAuth 2 identity providers in Couchbase Mobile 1.3. So if you have an authentication provider that supports OpenID Connect, which many of them do, you can just plug it into Sync Gateway. And you can also restrict access to the system to authenticated users and optionally allow unauthenticated guest users. Sync Gateway also has fine-grained RBAC for controlling data access for individual users and roles. It's elastically scalable in real time, so you can add and remove capacity in seconds, basically as fast as you can add or remove nodes in your load balancer. And in Couchbase Mobile 1.3, we added Sync Gateway to Sync Gateway replication. It's really awesome. It enables integrated support for topologies beyond star. So for example, think of a tree topology, which is very popular in enterprise applications. So one example specifically is in the retail industry. Under a star topology, POS devices can continue to work while they're offline, but then they can't share data with other devices while they're offline. So with a tree topology, a Sync Gateway and a Couchbase Server cluster would be deployed in the store data center and then configured to sync with the global data center. The POS devices would be configured to sync with the store data center. So under this configuration, the whole store can go offline as an entire unit, and then all the devices within the store will continue to share data with each other. So the same topology is useful for many other use cases. The retail example is just one. OK, and then backing all this, we have Couchbase Server, which is managing and storing data in the cloud. Couchbase Server is highly scalable. You can start with a few nodes and scale out, adding additional nodes as you need that capacity. Couchbase Server supports millions of concurrent users by leveraging memory and asynchronous operations. Like Couchbase Lite, it has that awesome, flexible JSON data model. And with Couchbase Server, you get 24/7 by 365 uptime by enabling replication and automatic failover. So Couchbase Mobile manages the data security concerns across the entire application stack. For user authentication, we support pluggable authentication. Like I mentioned, out of the box, we have support for the popular public login providers like Facebook, support for basic authentication, for OpenID Connect, or you can write your own custom provider. You can also restrict access to the system to successfully authenticated users or allow for anonymous users. For data read-write access, there are fine-grained policy tools that allow controlling data access for individual users and roles. Read-side permissions are at the document level, and write-side permissions are down to the field level. For data transport on the wire, for data in motion, that's over TLS. Data storage on the device, for data at rest on the device, we have 256-bit AES full database encryption. And for data storage in the cloud, for data at rest in the cloud, you can configure Couchbase Server to use file system encryption. So Couchbase Mobile is the full stack NoSQL database that resolves all storage, access, transport, and security concerns across the entire application stack. At the client tier, Couchbase Lite resolves the concerns of data storage, access, and security. On the web, we resolve the transport and security concerns associated with accessing, managing, and synchronizing data over the web. At the middle tier, you'll see Sync Gateway resolves the concerns of data access, security, and elastic scalability. At the database tier, Couchbase Server resolves the concerns of data storage, access, security, and scalability. So with Couchbase Mobile, you have a solution that resolves all the concerns of storing, transporting, securing data throughout your entire application stack. Okay, so now we talked about the key challenges earlier and the key criteria. How does Couchbase stack up? Well, guys, spoiler alert, we're awesome. We have integrated synchronization throughout the stack for easy integration. We have full offline support. We have cross-platform support for all the major operating systems, including a bunch of others. You can store both JSON documents and blobs, which includes the multimedia and sensor data. And we support more than just mobile operating systems, which includes IoT. And I'll talk about some IoT use cases a bit later. And what about the key criteria we talked about earlier? Well, we already talked about cross-platform. We have full stack security across the entire application stack. For data modeling flexibility, we have JSON support throughout the entire stack, super flexible. Sync configuration can be really easy. You can configure it how you want it, literally blue sky when it comes to synchronization. We support any conflict resolution strategy, including first in wins, last in wins, three-way merge, or anything else. Couchbase Server scales elastically with no downtime as your storage capacity demands increase, and Sync Gateway also scales elastically up and down in real time as capacity demands fluctuate. We support all network topologies. We can be deployed in any network topology, star, tree, mesh, ring, line, anything. Hybrids, anything. Okay, so now let's look at some Couchbase Mobile use cases. First, we have offline data access. So when users are cut off from important transactions because their app doesn't work offline, that's a problem. You need a local database for your apps to store data locally so that your app isn't dependent on the network. And you need a synchronization mechanism that allows your app to sync back to the cloud when network is restored. So let's actually dive into this a little bit more. We'll start with a typical deployment topology of today's mobile apps. So we have an app here running on a mobile device when we have a network connection. And when we have that, then the app will work as typically as expected. But let's say you start running into network issues. Well, that's why we have these UI components like spinners, progress indicators, and the like. The app is telling you that it's trying to do what you want it to do, but that you're going to need to wait a while for it to do that. And then what happens when the network becomes unavailable? Well, that's when you get messages like this: no internet, try again later. So what's the problem here? The root problem here is that apps store data in the cloud and then rely on an internet connection to access that data in the cloud. And this is what causes that slowness or that unresponsiveness. And if the network's available, then great. Everything goes as expected and the app works. But of course, we all know that we can never expect a network to always work. Once you start experiencing slow networks, then you start experiencing slow apps. So while the network can certainly contribute to the problem here, what this really is a data locality problem. Data location dictates app reliance on the network. If an app has to run to the cloud every time it needs to read or write any little piece of data, then it's going to have problems. If the network isn't available, the app can't get to the cloud and the app won't work at all. And if the network is slow, then getting data from the cloud will be slow, meaning the app will be slow. So what's the solution? It's all about your data location strategy. You need data local, which you get with Couchbase Lite, and you need data remote, which you get with Couchbase Server. And you need something that's going to keep those two data stores in sync, which you get with Sync Gateway. So Couchbase Mobile gives you the local data and the remote data, and it gives you the synchronization mechanism needed to keep your local data and remote data in sync. And that's what enables apps to work all the time. And we have some really great customers that are using Couchbase to build offline into their mobile apps. So Doddle is one example. Based in the UK, Doddle is a package collection and delivery service. I actually just got back from a trip to Europe, and Doddles were literally everywhere in London. They're in train stations, they're in airports, they're all over the city. And I got really excited every time I saw one because I know they're using Couchbase. So the offline and local processing capabilities are super critical to Doddle stores. Network connection was really hard to guarantee, but packages are delivered and picked up throughout the day, so any downtime can have significant impact on the Doddle business. So Doddle is currently using Couchbase Mobile to power its 50 some odd storefronts. Offline data access is really important. And they're using Couchbase Mobile for some other really important things like replication of data to source systems and eventing. So Doddle actually has a session here at Couchbase Connect. It's tomorrow morning, and I really encourage you to attend and to learn more. It's a fantastic use case around using Couchbase Mobile, and they're doing some really innovative things with the technology. Okay, so next we have local caching. So today's mobile apps require fast access to data. Storing and caching application data locally in your embedded device is a must because it eliminates the need for the app to constantly request data from the server. So Ryanair is one of our mobile customers using Couchbase Mobile in this way. For those who don't know, Ryanair is both the largest European airline by scheduled passengers carried and the busiest international airline by passenger numbers. So today they have around 3 million users planning over 80,000 flights per day using their mobile app. So the problem that Ryanair was trying to solve for was user experience associated with the time it was taking to complete a booking on their mobile application. We love their story here at Couchbase. So you know what I'm going to do? Instead of telling you about it, I'm just going to show you. So this is a comparison of Ryanair's mobile app before Couchbase Mobile and with Couchbase Mobile. You'll see on the train below, this is the gray lines with the yellow dots, how quickly the app running on Couchbase Mobile hits landmarks like finding flights, seat selection, and more. The old app is the top line, and the new app is the bottom line. So on the left is the original application. This architecture was a hybrid mobile app using REST services backed by a relational database and cache. In this architecture, the mobile device talks to the web server via REST, which retrieves data from the cache and/or the database. The cache and the database here are separate systems. So with this old architecture, bookings were taking more than 5 minutes to complete. Data had to be retrieved from the server during each booking request, which was increasing the amount of time it was taking to complete a booking. And over 80 gigs of data was being transferred to mobile apps per day to drive this booking process. So on the right, you'll see the app running on Couchbase Mobile. With Couchbase Mobile, Ryanair moved to a synchronization architecture. Semi-static data is cached locally in the embedded Couchbase Lite database, and then it's automatically updated via Sync Gateway when it changes in the cloud. So the app always retrieves the data from the embedded database, which eliminates the need to constantly request this data from the server. As you can see, the mobile app experience is now so much better. Additionally, the booking process is about 60% faster. It was slashed from over 5 minutes to under 2 minutes. Network traffic to drive bookings is 87% more efficient, so reduced from 80 gigs a day to 10 gigs a day. And as you can tell, the user experience is vastly improved. So really exciting use case. You can see it for yourself, the difference in moving to this local caching sort of environment, how it made such a great difference for the Ryanair mobile app. And we actually don't even get to see the old app finish because under Couchbase Mobile, the person was already able to purchase their tickets. So very cool use case. Ryanair is also a really great example for those of you that would want to take advantage of Couchbase Mobile in your existing mobile apps. There are so many great ways to do this, and this is just one way of doing it. Caching semi-static assets locally within your application and using synchronization to update them as they change. Okay, so next we have digitization of paper assets. So reducing operational time and cost is critical for any business. Digitizing paper assets allows you to save time and resources, helps you reduce storage, and cut logistics costs. So some of our airline customers, for example, are using Couchbase to digitize the cockpit processes. So if you didn't know, and I certainly didn't realize this before I really kind of dug into it, there's a massive amount of paperwork that pilots are required to complete before they can take off. So digitizing that paperwork has saved pilots so much time. It's streamlined the takeoff process, and it's helped get flights out earlier. And this is what the digital economy is about. It's taking old legacy processes and digitizing them, sometimes literally. So we have a ton of customers who are using Couchbase to digitize their paper-oriented processes. So next we have content delivery and storage. So guaranteed delivery and storage of assets is crucial for a great user experience. I've talked about this before, but you need the ability to store and access data locally on your device so that content is always available for your users. Product orders, electronic tickets, reservations, service requests, customer profiles, just a few examples of content that needs to always be available for today's mobile apps. So BD is using Couchbase for content delivery and storage, and I'm really, really excited about this one. So if you don't know, BD is a Fortune 500 billion-dollar technology company. Their Couchbase Mobile use case is pretty incredible. So BD has a mobile app that patients with diabetes use to track their glucose levels. The app they've built is not only collecting this patient data, but it's also helping with interventional care for diabetic type 2 patients. It's helping improve the patient-clinician interaction to lower diabetic incidence. So instead of patients having to visit their doctor, show their results, and have the doctor respond based on the results they see that day, doctors can now get that information in real time as the mobile app is updated. So this is radically changing the patient-doctor relationship, Now doctors will have this information before patients visit them, enabling them to provide some up-to-date recommendations, analysis, and more to their patients. So I won't go into all the details because they are presenting their full story tomorrow here at Couchbase Connect. Such a cool use case, super inspiring. I hope you guys can make it to learn more. Okay, then we have real-time data tracking. So tracking, storing, and delivering real-time data updates can be really tricky to manage. It's data that may be shared across tons of users, or maybe it's data that's shared up management chains. Maybe it's a major logistics company where supervisors need real-time visibility into their drivers' schedules, routes, pickups, and drop-offs. Access to that kind of information gives businesses the ability to provide real-time customer service, which is so critical in today's digital economy. Then we have peer-to-peer device usage. So this use case is becoming more and more common. We're starting to see it quite a bit in the field. In isolated environments like retail stores, planes, in the field, or other places where the network isn't reliable, the ability for devices to talk directly to one another is really critical. At a very high level with peer-to-peer, apps can connect to exchange data and will continue to work regardless of network availability. So let's just look at a quick example of peer-to-peer. This is an airplane with devices on board that are connected to a data center. What you see here is Couchbase Mobile deployed in a hybrid tree or /mesh topology. So this is an example of peer-to-peer replication and how you can get the benefits of that. So the airplane is connected by the A and B endpoints. In this case, device 2 has left range, you can see that at the top, from the A endpoint, which is a central endpoint. But if devices 1 and 2 were to use peer-to-peer, then they would be able to create a peer-to-peer network between those two, which means that device 2 can continue to operate offline, but also continues to share data with the rest of the network, even though it doesn't have a direct access path to the network itself. So peer-to-peer is very powerful. It's gaining a lot of traction, like I mentioned, and it might be something you guys might be interested in. Can we do questions at the very end? We'll have a bunch of time. Is that okay? Okay, so last we have IoT, which actually is its own use case and expands beyond mobile. So a logo you're probably familiar with is GE. GE is using Couchbase Mobile to power its Predix platform, which is its software platform for the industrial internet. Predix connects machines like trains, wind farms, submarines, and so much more. All kinds of things that are counted on to work all day, every day for the next 25, 30, 35 plus years. So connectivity is mission critical here. These machines are literally everywhere. They're in the middle of an ocean. They're on top of a mountain. They're inside of a wind turbine or in a rail yard. And even then, those machines have hundreds of moving parts, all of which need to be tracked and maintained. So what Predix does is it ingests all of this machine data, it stores it, it cleans it, it analyzes it, and it takes all this critical information back to the operator. and it provides that information at massive scale. So Predix must be reliable 24/7, and Predix relies on Couchbase Mobile for this. So in addition to being a pretty cool IoT use case, offline capabilities are also really important for Predix. One of my favorite things that Mike from GE talks about a lot is the idea around offline first being the new mobile first. Offline capabilities are critical for Predix. GE is also a really great example of a legacy company adapting and evolving its business to be a major player in the digital economy. You've probably seen a bunch of their commercials on TV. So GE is presenting later today. I hope you can attend. They'll be going into a ton more detail around Predix and how they're using Couchbase. So these are just 4 examples of some really great customers building some really amazing mobile and IoT apps using the Couchbase data platform. We're seeing a lot of innovation right now. The airline, travel, healthcare, education, e-commerce, gaming spaces, from Fortune 500 companies to 10-person startups. Couchbase Mobile is being selected as the backing technology for so many mission and business critical applications. Okay, so I just wanted to spend a few minutes talking about the conference and what to expect specific to mobile. So if you're brand new to Couchbase Mobile, if you're evaluating Couchbase Mobile, if you're using Couchbase Mobile, or if you're a ninja in Couchbase Mobile, I encourage you to take advantage of the next 2 days. Our entire engineering team is here. That's the team that's actually building our product. They'll be presenting sessions throughout the next 2 days, so find them, talk to them, attend their sessions, ask them questions. We've set up the mobile track in a way that you'll get hands-on experience for the entire product lifecycle. And we have some really great customers that will be sharing how they're using Couchbase Mobile to build some really amazing apps. So in the next session, you'll start with how to design applications using Couchbase Mobile, including architecture, data modeling, and security. After that, you'll go through how to develop applications using Couchbase Mobile's database API, synchronization, and security. Next, you'll learn how to perform functional, scalability, performance, and reliability tests on your Couchbase Mobile application. And then we'll dive into more technical specifics with the products, including how to set up Sync Gateway as a service platform, a session on what to expect in Couchbase Lite 2.0, and the operational aspects of Couchbase Mobile, including replication topologies and deployment strategies. We also have some phenomenal customers sharing their stories. I mentioned most of them: GE, Market America, Doddle, and BD will be presenting in the mobile track over the next 2 days. So really great stuff. I also hope that you can attend the keynote tomorrow. It's a mobile and IoT keynote, and our head of mobile, Wayne Carter, will be talking about the vision for our products, and that's during tomorrow's keynote. So make sure to attend if you're here. So with that, we're really excited to have you at the conference, and we look forward to spending the next 2 days with you guys. We have time for questions. I'm actually going to bring Wayne, our head of product, up so you can ask him specific questions about the product as well. So I think you had a question.
I was just wondering what communication are you using between one and two?
For peer-to-peer.
It's over HTTP, but
I'll repeat the question. So what's the communication being used between devices 1 and 2 in the example I showed for peer-to-peer?
okay. So it communicates over HTTP just like it communicates with Sync Gateway. Now we don't manage the network, so it's going to be dictated by the device capabilities. So if we can do HTTP over any type of technology, then we can use that. So it'll be really about the device's ability to create an HTTP connection.
Any other questions, guys?
Any other questions?
I must have answered them all in my presentation. There we go.
You talked a lot about scenarios where the data is actually stored somewhere in the server and you're pulling it using the sync service, but do you have any stories where the data is actually created at the endpoint and how you manage syncing that up to the backend?
Yeah, actually a lot of those were also data originating at the mobile endpoint. So BD is an example of that. The data is actually pulled off the glucose meter on the mobile device. So there's a connection between those two. Is this working? No?
Here. Here.
Let me just save. the way that's done is there are replicators in Couchbase Lite, which is the embedded database, that acts as the active participant in replication. So it connects to the remote endpoint, which could be Sync Gateway. It can also be another Couchbase Lite instance if you're doing peer-to-peer. And then you control your replication strategies from Couchbase Lite. So there's two types of replicators, pushers and pullers. They can be configured in two different modes, which is one-shot, which means they connect to the remote endpoint, catch up, and never run again. And there's continuous, which means that they will connect to the remote endpoint and just continually sync as changes occur on either side, depending on push and pull. And then the replicators have a lot of filtering capabilities for managing what data is replicated by the replicators. So that allows you to replicate data at different speeds through your application. You can also have one or more replicators, actually 0 replicators if you don't want to replicate, if you just want to use it as an embedded store. But you can have as many replicators as you'd like replicating your data at different rates. So for example, chat data, you'd want to replicate in near real time. Log data, not so much. Or maybe just when the app goes up and down.
So follow-up question then. So again, in our use case, we have a lot of field mobility users where they take a large set of data and actually they're creating data sets on top of that.
Mm-hmm.
So if in this case, if each one of these, let's say you have hundreds of mobile users and each one of these guys are in different states with that data, so is the replicator or the engine in the back end keeping track of who has what data sets so that when they connect back, it knows what deltas to give to these endpoints?
Yes, absolutely. So that's a core part of our replication. So on the back end, the security policies that Ali talked about are actually what dictates what a user can see. So there's read-side policies for what can be read. There are write-side policies for what you can write down to the field level. And then there are filter capabilities on the replication where you can say, because when you define the policy, you can create, there's slices of data that you can define. They're just named slices, like might be contacts, it might be Wayne, right? Just really arbitrary sets of data that you define. It can be as large sets or very fine-grained sets. And then the replicators can be configured to sync everything, which is going to be a union of all of my permissions, or specific slices of my permission, where you might want to, take down certain things at different times, et cetera. Okay, go ahead.
What's the feasibility of like kind of a 4-stage thing? So they have a data center with Couchbase Server and a sync gateway. Then I have like hundreds of retail locations where I have like a Couchbase like instance there.
Yeah.
That's kind of a master. So I have people roaming in and out with Couchbase Lite as a peer-to-peer to that.
Yeah.
Is that very feasible?
It is. Couchbase, another way of doing it is to deploy a Couchbase Server Sync Gateway cluster. It depends on how big the store is and how many devices you need to connect to it. If it's relatively small number, 15, 20, something like that, then deploying a Couchbase Lite instance in a tablet or on a embedded computer or whatever, and using peer-to-peer as your replication strategy is acceptable, and we see that actually in our customer base. After you go above that, you're going to want to use something that's designed more for highly concurrent users. The embedded database is, it takes some concurrency, but it's not designed specifically for that. Any other questions?
The backend infrastructure can be hosted on-prem, cloud.
Exactly. So it deployed on whatever servers you'd like and whatever cloud you would like. You can be in your private data center, it can be in a public data center, Azure, AWS, Google Compute, a bunch of other ones. So it's just up to you where you want to deploy.
I'm going to give a demo later of deploying a Docker cloud.
So if you want to know specifics on those different areas of the product lifecycle that Ali talked about, then you go to those and they'll talk in more detail about that area. So deployment and testing is in the same session, but the deployment session is where Tron will be talking about that. Tron's an engineer on the Sync Gateway, by the way. Go ahead. Yeah.
So she said all those nice things, design, testing, so where do we learn all those things?
In the session, so there's, in your session guide, there's a purple set of sessions. Those are the mobile ones. And so if you look at each session slot, there'll be a mobile session that you can go to, and there'll be these that she's talking about. So design is the next one, which is, it depends on what your role is in your organization, but that would be on the architecture side, right? So if you need to know how to design your app from a modeling and security perspective, that's where you'd want to go there. I think that's useful for pretty much everyone, even if you aren't serving that role. Develop is for developers, so how do you actually use this technology? How do you write code against it, CRUD, query, replication, security, et cetera. And then testing and deployment are in the same one, and then some more advanced session as you go forward. Okay, any other questions? All right, thanks a ton.
I got one.
Tron has one.
Hey Tron, what's up?
I've seen a lot of trend in like medical devices that
Yeah.
they're kind of like Fitbit style devices that sync to the phone.
Mm-hmm.
Do we have any? Is that a use case for Couchbase Lite? Like, do we have something where basically you could, if I was going to make a Fitbit tracker,
Yeah.
With really small requirements, can I run like some version of Couchbase Lite on that and then push it over Bluetooth to the device?
If the device you're talking about has the compute capacity that's required by Couchbase Lite, then yes, you could run it. But Couchbase Lite isn't designed for super constrained environments. So if you want to do that, you might want to talk over HTTP, where you can talk to Couchbase Lite. So you can expose the REST interfaces using the listener, and then have your more resource-constrained device talking to Couchbase Lite over a secure network connection. So HTTP or Bluetooth, or you could also create your own endpoint that then, if you want to talk over some other protocol that we don't support, you could talk over that protocol and then talk directly to your Couchbase Lite instance and on the other side of that bridge in the mobile side. Okay.
So what would you say is the min requirements for it?
We've tested it on Raspberry Pis, which are
Raspberry Pi 1?
a Raspberry Pi B is where we've tested it, which is still a pretty powerful device.
That's why I'm asking.
Yeah. It's a database, so it's a full database. So you need a
Did it run snappy on the B or no? Was it about
pretty well. The disk I/O on the B isn't great, so that's going to be your bottleneck is disk I/O speed. But you can get higher disk I/Os by using some of the other interfaces, not the SD interface. You could use the USB interface if you like. But on the B specifically, Raspberry Pis are educational devices. You might want to move to something like a BeagleBone or something that's more designed for actual commercial use. Similar price points, but not exactly the same. But it does work on those devices, and they're pretty small form factors. And there's even smaller ones than that. Yeah, exactly.
Performance that everybody knows.
Yeah, B is probably a good one to use as a reference point.
Okay, so that's about min.
It's about min.
What is it called? B?
Raspberry Pi B. That's just an embedded computing platform. Yeah. All right.
Thanks, guys.
Thanks.